In today's video, we'll cover the dilution method. In order to successfully complete a dilution, it is important to understand the method and calculations associated with the measure by difference method and concentration formula. Understanding our molarity formula, moles over volume, we are able to determine the unknown concentrations for all three solutions. This is due to understanding our known molarity M1 and inserted volume V1 of each solution and setting it equal to an unknown concentration M2 and a known second volume of 25 milliliters or V2. This formula will remain true across all three dilutions. By dissolving 0.265 grams of copper 2 sulfate in water using a plastic pipette, we are able to complete our first step in achieving a desired stock solution. Before moving on to the next step, we need to make sure that we completely dissolve the copper 2 sulfate in the water solution. After completely dissolving your salt in the water solution, we can now add aqueous ammonia in order to ensure our stock solution has an observable concentration. To check, make sure your solution has a dark blue coloration and is clear. After adding the aqueous ammonia to your stock solution, you can now fill water to the 25 milliliter line. That way we have a constant volume for all our dilutions. It is also important to make sure you do not exceed the 25 milliliter line, or you will have to start over due to your solution not having the right amount of volume. The meniscus is the surface level or top of your solution in a given piece of glassware. In order to correctly pinpoint this volume, you must fill your solution to the intended mark by viewing the glassware at eye level. For example, after each insertion of water into the volumetric flask, I hold the flask at eye level to determine it has met the 25 milliliter mark. After your stock solution is completely prepared, we can now transfer it to a graduated cylinder. This will ensure that we have easy access for our next dilutions. We are now able to transfer 5.02 milliliters into our volumetric flask for our first of three dilutions. It is important to use the method of measuring the difference with a granulated pipette, measuring the initial and concluding volume. Now add water to each transferred solution by filling the volumetric flask to the 25 milliliter marker. Remember, it is important to not exceed this marker or you will have to restart your dilution. It is also important to ensure your solution remains clear. If not, add more ammonia to your solution. By transferring dilution 1 to make dilution 2, it is important to record your initial volume of 8.75 milliliters and your final volume of 2.91 milliliters, which will give you a transferred volume of 5.84 milliliters. It is important to measure your meniscus in a granulated pipette by reporting its initial and final volume to the second decimal place. Remember to record each volume at eye level or your measurement will be off. By transferring dilution 2 to make dilution 3, it is important to record your initial volume of 8.98 milliliters and your final volume of 3.53 milliliters, which will give you a transferred volume of 5.45 milliliters. With every lab, it is important to clean and properly store all equipment used in your experiment. For the dilution lab, all solutions can be deposited in the sink. Once you finish cleaning the appropriate glassware, you are then able to store it in its designated location within the lab.